Hello students, welcome to Educate. In the last class, we have discussed about question number 1.24. From 1.25 onwards, now we discuss. 1.25 is asking how are 0.5 mole Na2CO3 and 0.5 molar Na2CO3 different. Guys, 0.5 mole Na2CO3 informs you about the number of particles. That is 0.50 mole Na2CO3 means number of particle is 0.5 into 6.022 into 10.23. That much Na2CO3. Where about that? No information is here. That means there will be a sample here. Just like that, there will be an amount of Na2CO3, and in this case, the number of moles is 0.5. But 0.5 molar Na2CO3 means Na2CO3 here is acting as a solute. That means here 0.5 mole of Na2CO3 is present in 1 liter solution. 0.5 molar Na2CO3 or 0.5 molar Na2CO3 means 0.5 mole of Na2CO3 is present in 1 liter solution, and 0.5 mole Na2CO3 means the number of particles of Na2CO3 is 0.5. Okay. Now question number 1.26. If 10 volumes of dihydrogen reacts with 5 volumes of dioxygen gas, how many volumes of water vapor would be produced? Okay, so let's see here. Read the question firstly, because I am making these questions, that means I am making this one short. Let's see. There is reaction between dihydrogen and dioxygen. So let's see, firstly write the reactions for dihydrogen and dioxygen. And here already given that water vapor is producing. So hydrogen react with oxygen and there is formation of H2O. Now balance the question. This one. Now 2 volume according to, because when the condition of temperature, like this one, a container here. So what will be the pressure? That will be here. Pressure, volume is constant. So volume of hydrogen will be also, okay, let's see. Why this one? Because someone tells, let's see, like this is a container here, its volume is V. Here hydrogen and oxygen is there. And that's react to give H2O. H2O here, it is in vapor phase. So volume of hydrogen is V, volume of oxygen is also V, and volume of water vapor will be also V. Someone will tell that why not there be division of the volume? Volume should be divided among hydrogen, oxygen and water. Why that not divide? Because hydrogen particle will distribute uniformly over whole of the container. In the same way, oxygen here O2, that is also distributed in whole of the container, and water vapor will also distribute in whole of the container. So that's why volume of oxygen will be the volume of container, the volume of hydrogen will be also the volume of container, and volume of water vapor will be also the volume of the water container. And what will be the temperature here? So temperature same for all of them. Like that, if I tell that India is my country, you will tell that no, India is my country. And someone, your friend, will also tell that no, India is my country. So is it that if India is your country, then that's not of mine and that's not of your friend? How's India is my country or it's your country? Because I can go anywhere in the India without any visa. You can also go anywhere in whole of the India without any visa, and your friends can also go anywhere in the India without any visa. So that is here. So that is, if you are telling that India is my country, I can also say that India is my country. Your friends can also say that India is my country. In the same way, volume here of the hydrogen will be equal to volume of container. The volume of oxygen will be equal to the volume of container, and the volume of water vapor will be also equal to the volume of container. Okay. So now let's see here. So here volume, how much? By the Avogadro's law, you have studied that during a chemical reaction, the reactants reacts together in terms of their volume, and product also there will be in terms of their volume. And Avogadro's law also you know that is Gauss-Lilje's law of combining volume. That is here by the Gauss-Lilje's law of combining volume. You have studied that the ratio of volume occupied by the hydrogen and that of oxygen will be a simple whole number ratio. In the same way, the volume occupied by the oxygen and that of water vapor will be also a simple whole number ratio, and volume of hydrogen and with the volume occupied by the water vapor, that will be also a simple whole number ratio. That's why Gauss-Lilje's law of combining volume. And Avogadro's law that states that at the same conditions of temperature and pressure, equal amount of every gases occupy same volume. Okay, so here let's see. So 2 volume of hydrogen will react with 1 volume of oxygen. So there is 10 volumes dihydrogen is reacting and 5 volumes of dioxygen is forming. So here its volume of hydrogen is how much? 10 volumes. So 10 volume here, and its oxygen volume is here how much? 5 volume. So obviously 1 volume of hydrogen will react with 1/2 volume of oxygen. So 10 volume of hydrogen will react with 1/2 into 10. That means 5 volume of oxygen. So how much water vapor will produce? So obviously here no limiting reagent, both will consume in the reactions. So here 2 volume of hydrogen gives 2 volume of water. So 10 volume of hydrogen will give 10 volume of water, since 2 volume of hydrogen produces by hydrogen you may take, or by hydrogen oxygen also. 5 volume or 1 volume of oxygen gives 2 volume of water vapor. So 5 volume of oxygen will give 10 volume of water vapor. Very simple question was here 10 power minus 12, 10 power minus 12 milligram means 10 power minus 3 gram. Very here 10 gram kg, so that 10 power minus 3 gram here multiply by into 10 power 3 milligram here, so 10 power minus 3 gram, and into kg, so 10 power minus 7 3. That means that into 10 power 6. 1 2 3 4 5 1 2 to 4 5. So 0.02 0.0, so 0.025365, that much kg. Basic unit of the basic unit will be gram here, so that's why this much kg. Meter, so 10 power minus 12 meter, 10 power minus 12 meter, multiply there. Now let's see. Watch out here. There is gold. Yes, AU is gold. atomic weight 197. Sodium here how much? 23. Lithium, watch out, 3. So 3 to the 6, 1, 7. So 7 here, and chlorine, that is atomic weight is 35.5. Okay, largest, which of the following will have the largest number of atoms? So largest number of atoms. So whose atomic weight will be least? That will be the largest number of atoms. Because how to find out number of, okay, whose atomic weight will be least? In that one, the number of, because weight is a constant. Weight is constant. So whose atomic weight will be least? That will be the largest number of atoms. In other words, the number of silver atom will be how much? That will be 1 by 197 into 6.02 to 10 by 23. Same number of sodium atom, that will be equal to 1 upon 23 into 6.022 into 10 by 23. Same for the lithium. So here numerator a constant here. So least number of atoms will be in the of the gold. Sorry, here not silver, gold. Here 197, here 23, here 7. So obviously minimum in the gold, then after in chlorine, then after sodium, and maximum will be in lithium. So that's why this one. Okay, not to calculate also. Simply watch out, since atomic here number weight is given. So whose atomic weight will be least? Whose atomic weight will be least? That will contain maximum number of atoms, and whose atomic weight will be largest? Their number of atoms will be least. So now let's see another question. Question is here, calculate the molarity of a solution of ethanol in water in which the mole fraction of ethanol is this much. Listen. Mole fraction is given and it's asking molarity of the solution. So what's the meaning of mole fraction? Means if the total number of moles of the solution will be 1, then what will be the number of moles of, then what will be the number of moles of here ethanol? That will be called molarity of the solution. So let's see here. Assume the density of water to be 1. Density of water here 1 already given. So let's see. So number of moles of ethanol will be 0.02040. Okay, so mole fraction here, so 0.040, that will equal to number of moles of ethanol upon number of moles of ethanol plus number of moles of water. Okay, it's asking number, assuming the density of water will be 1. So this one here, so number of moles of water here, this one. So number of moles of water will be how much? Number of moles of water will be how much? 1 minus 0.040. How much is coming? Density of this is 1. Density is 1 here. So Number of moles is this much. Number of moles of ethanol is this much. Density is 1. So let's see, mass of ethanol will be how much? Into molecular weight of ethanol. This one done. Now let's see here. I'm rubbing these portions. So total that is mass of water is this much, mass of ethanol is this much. Molarity you have to find out. Assume the density of water here to be 1 here. This one is given. So total mass of the solution will be how much? So 17.28. (19.04). This one is the total mass of solution, and since density is 1, so since density is mass by volume and density is given 1, so mass is 19.04, so volume will be 19.04, that much milliliter. In liter, that will be 19.04 into 10 power 3, 10 power minus 3, that much liter. Okay, till here, no problem. Then after, let's see. Number of moles of ethanol, how much? Okay, so that will be 0.040. So molarity will be, so that much, so molarity will be 0.040 upon 19.04 into 10 minus 3. That much. Okay, calculate that, you will get what will be the answer. Okay, now next question is, what will be the mass of one carbon 12 atoms in gram? Okay, first of all, let's this one. Here I hope no problem here. Now let's see about this question. Mass of one. So that means you know already the atomic weight of carbon is 12. The atomic weight of carbon is 12. That means when the number of carbon atoms will be 1 mole, that is 6.022 into 10 power 23, then their weight will be 12 gram. the atomic weight of carbon is 12. That means when the number of carbon atoms will be 6.022 into 10 power 23, then their mass will be 12 gram. So let's see here. So it's asking of one carbon how much weight. So weight of 6.022 into 10 power 23 atoms will be 12 gram. So weight of one atom will be how much? Unitary method there is. So let's see. In the examination, how to do? Here, either when you divide 12 by 6.022, what is here? That is the time taking process. When you will divide 12 by 6.022, that will be the time taking. So just let's see here. So it is 6 to the 12 approximately, but it is more than something 0, something more than 1 here. That means something more than 6. So that will be 1.99 over 23. So weight of one atom of carbon will be 1.99 into 10 raised to the power 23. Okay, this one is related to the physics. Here, should I solve? This question I am doing here. But I have not taught you of the physics, the concepts of the physics. That means this topic is also in physics as well as in chemistry, and in physics that is in more detail. So that's why I have left. I have not taught you about the significant figures here, but this question I am solving. How to do? Okay, I am telling you the hint about what happened. This is the multiplication here. So during multiplication, you will have to report the answer in such a way. That means when you will have to do the round off, then you will have to do the round off in such a way that will contain the number of significant figure present in the number in which the number of significant figure will be list. Like as for example, first of all, multiply this one. Multiply. Okay, let's see here. This question is frequently asked, but that was asking here, particularly in NEET examination, very frequently, and most frequently it was asking in the NEET examination, and that was in AIEEE examination. So this type of questions may ask in the physics examination, physics also. So okay, in chemistry also this type of question has been asked, but since I thought that means first of all you watch out from the physics. That's why I have not taught you there about the significant figures. So let's see here. So when you multiply these values, this one, when you will multiply, so you take out all the figures like that, it will come 1.6485, 1 point, well, after calculation, multiplying and dividing, that will come 1.64, 1.6485710769. That is here. Now how to report? Watch out here in this case. Here significant figure is how much? 1, 2. In this number of significant figure is 4, because zeros left to the decimal, left to the first non-zero digit. The zeros left to the first non-zero digits are not here significant. The zeros left to the first non-zero digit are not significant. That's why here number of significant figure is 4. So in this case number of significant figure 4. Here how much number of significant figure? So all the non-zero digits are significant. So here that is 1, 2, 3, 4, 5. 5 significant figure. So here number of significant figure is 5. In this case 1, 1, 2, these 3 is the number of significant figure. So here number of significant figure is 3. And in denominator number of significant figure is 4 here. So least number of significant figure is 3 here. So you will have to report this value so that there will be, you will have to report this value so that there will be 3 significant figure in that report. So 1, 2, 3, this one. So you will have to round off here. So that means after that, till when you are taking this value, that means fourth one is more than 5. So this value will increase by 1. So that will be 1.65. Guys, in the examination option, the option will be 1.64857. Another one 1.6485, like that. So you will have to keep in the mind that during this one we will have to first of all calculate and will have to report during multiplication and division in the reported value, the number of significant figure will be equal to the number of significant figure which will present in the figures containing less number of significant figures. Okay guys, this one, then after here next one, this 0.5 into this one. Here when any value multiplied by the whole number, so during that course this one will be contained in a finite number of significant figure. So here only 4 significant figure. So what will you will multiply? After multiplication you will write. In that case the number of significant figures should be only 4. Like that. Okay, let's see here also. 5 4 20, carry 2, 6 5 30 and 2, 32, carry 3, 5 3 15 and 3, 18, carry 1, 5 5 25 and 1, 6 26. Decimal is after 3 digit, 1 2 3. So here there is 4 significant figure. So your reported value should also contain 4 significant figure. This one is 0, that is less than 5. So that will be 226.82. During addition, the number of digit, that means after the decimal, the number of digit will be equal to the figures in which the number of digit will be minimum after the decimal. Let's see into this one. So firstly add this one, 0.0125 by 0.7864. That means these 3 values firstly add. During addition and subtraction, we will have to consider the number of digit after the decimal, and during multiplication and division, we will have to consider about the number of significant figures. In which one case will be least, that will be the reported value. Now here, in this case, number of digits after the decimal is how much? This much. I'm not considering about the significant figure. Only number of digits after the decimal. So here 4, here 4, here also 4. So you have to report like this. So that will be the answer. Okay. Now this question. About these questions, I have already discussed about this question. So that means here I hint you if you feel the difficulty. So argon 36 have the relative atomic mass or isotopic molar mass. That is called isotopic molar mass, or that's also called relative atomic mass of argon 36. So isotopic molar mass of argon 36 is this much, or in other words, the relative atomic mass of argon 36 is that much. In the same way, the relative atomic mass of argon 38 is this much, or the isotopic molar mass of argon 38 is this much. In the same way for argon 40. So how to do that? So this into this, okay, after addition that will come 100. So this into this plus this into this plus this into this upon 100. That will be the average atomic weight of argon. This type of questions we have already discussed. That's why I am not discussing about this question. Here number of atoms to calculate. This one is very easy here. 52 moles of argon. So 52 into atomic weight of argon. Okay, about these questions we discussed, because here that's different. So let's see how to solve this question. What's the meaning? Meaning changes here. So otherwise this question is not difficult, but maybe some students have not listened to the lecture so much sincerely. Maybe he have missed. So that's why I am discussing about this question also. But this question is quite easy. Who have studied, who have watched the videos of Educate sincerely will feel these questions too much easy. So, but let's see here. 50 argon atomic weight is how much? Argon atomic weight 18. So, atomic number 18. So, 18 is a even number. So, that's why atomic mass will be simply 18 into 2. So, that is 36. That is, so atomic weight of argon is 36. Means when the number of moles of argon will be 1, then their weight will be 36. So there is 52 moles. So 52 moles will come to how much? That much. You multiply by yourself. Second one is 52U. So 52U means here atomic weight, that means here that much. So 52U means here helium. So 52 into their atomic weight. Same 52 gram of helium. So that means helium atomic weight 4. So 4 gram, then their atomic weight is number of atoms you will have to calculate. Oh, number of atoms you will have to calculate. It is 52 moles of argon. Sorry guys, here number of atoms have to calculate. So simply here 52 moles. So 52 into 6.022 into 10 by 23. Number of moles of this one. 52U of helium. So 2U. Helium atomic weight is 4. So when 4U. Atomic weight of helium is 4. So 4U. So when there is 4U, then their number of atoms will be 6.022 into 10 by 23. There is how much? 52U. So same, very simple here. That will be, and of this one 52 gram of helium. So atomic weight of helium is here 4. So 4 grams, that means 4 gram, when there will be 4 gram helium contained. How much? 1 mole helium. That is number of atoms will be how much? Or 6.022 into 10 by 23 helium atom. Atomic weight of helium is 4. that is for you, or it is you. So atomic weight of 4 gram of helium contain one more helium or that much atom. So that is how much? 52 gram. So 52 gram will contain how much? See, like this. Not here 44, it is U. Okay, so that is. Guys, this question was very easy, but since that was conceptual, that's why I have discussed about those questions. Maybe some students feel difficulty when they try to solve this question. So now let's see about this one. To this question, and this question is good, and this type of question asks, let me say a questions of this type question asked in the IIT main examination. So watch out how to solve this question sincerely. That means not here, watch out how I am solving, what the concepts involves during solving of these questions. Watch out that sincerely. So let's see. Read the question firstly. I am zooming this one so that you could read the question easily. Read the question. Now I am sorting this one, and then after solving this question. There is CXHY, suppose Y, that is formula. So when that's burned, so there will be formation of CO2 and H2O. This one, here X, here Y by 2. But here how much carbon is, that we will have to find out. So that is CO2 forms how much? 3.38 gram CO2 is forming. So weight of CO2 is here 3.38 gram. That, and then after here weight of water is given 0.690. So weight of water here also 0.690. That much clear. How much carbon here is and how much hydrogen will be there? Because that molecule is made up of only carbon and hydrogen. That molecule is made up of only carbon and hydrogen. That's why we will have to firstly find out the number of carbon atoms and that of oxygen hydrogen atoms, or number of moles of carbon and the number of moles of hydrogen. That's we will have to firstly find out, and then after what in which ratio they are, that we will get there. So during that course we will get the empirical formula of that molecule. So here is 3.38 gram carbon CO2 is there. So let's see here, molecular weight of carbon is CO2 is 44 gram. How's molecular weight of this one? That means 44 gram of CO2 contain how much carbon? 12 gram carbon. Obviously, when CO2, total weight of the CO2 will be 44 gram, then weight of carbon will be 12 gram. So there is how much? 3.38 gram CO2. So 3.38 gram weight of 3.38 gram CO2 will be how much? That is here. In the same way, you can find out about the hydrogen also. So there, water here, 18 gram, molecular weight of water 18 gram. So 18 gram water contain 2 gram hydrogen. So there is how much? 0.690 gram. So that's what you will have to find out. 0.690 gram of CO2 will contain how much? So 2 upon 18 into 0.690. How much is that? Calculate. This one here? No. So carbon, how much is there? Hydrogen, what's the weight of carbon here? What's the weight of hydrogen? That you have calculated. Now you can calculate the number of carbon atoms and that of the number of hydrogen atoms. So number of carbon atom will be how much? 0.922 divided by 12. And number of hydrogen will be 0.077 divided by 1. That is here. So no, 0.077 here, also 0.077. Both have same quantity, same here. So ratio of carbon and hydrogen is 1:1. So ratio of empirical formula will be CH. Okay. Now then after here, that's so empirical formula you got. So it's a molecular weight indirectly has also given. That is when volume is 10 liter, their weight is 11.6 gram. You know at STP, 1 mole of any gas occupy 22.4 liter volume. And in this question, it has been provided that when the volume of this gas is 10 liter, then their weight is 11.6 gram. So when volume will be 22.4 liter, then the weight of the gas will be equal to the molecular weight of that gas. So that's here not given. So that's we will find out. So let's see here. I'm rubbing this one. So what here 10 liter volume, (11.6 gram). So when the volume of this gas will be 10 liter, then its weight is 11.6 gram. So you will have to find out when its volume will be 22.4 liter. Then what will be there? That is 25.99. Okay. So watch out here. Molecular weight is this much. Empirical formula. If you divide the molecular weight by the empirical formula weight, you will get on number, and same number when you multiply it to the empirical formula, you will get molecular formula. Because what is here, the empirical formula is the in which ratio different elements are present in the molecule, and the molecular formula is the actual number of different types of atoms present in the molecule. So here, in other word, the molecular formula will be the multiple of the empirical formula. So molecular weight will be the multiple of empirical formula weight. So here I am getting the empirical formula weight. Molecular formula weight you know already. So about that one we discuss here. So here empirical formula weight will be how much? (12 plus 1), that is 13. And here molecular weight is 25.99. So molecular weight first we get molecular weight upon empirical formula weight, or molecular formula weight, or you may also write molecular formula weight divided by empirical formula weight. So that will be 25.99 divided by 13, nearly 2. So that means here CH is the empirical formula. So when you multiply by 2, then you will get the molecular formula. So hence molecular formula will be C2H2, that means that is acetylene or ethine. Okay. Now watch out this question. 1.35. Read the question. So watch out guys. Here the concentration of the solution has been given and the volume has been given. So how much number of moles of HCl will be there? That can be find out. And here 2 moles of HCl react with 1 mole CaCO3. So that much moles of HCl will react with half of the CaCO3. What's the number of moles here? From here you will find out the number of moles of HCl in the solution, and by the reaction 2 moles of HCl react with 1 mole CaCO3. So here that much moles of HCl will react with how much CaCO3, that you will find out. And when you will find out the number of moles of CaCO3, then by multiplying by the molecular formula or the formula weight, you will find out the weight of CaCO3 required to react completely with the HCl solution. Okay, maybe someone felt difficulty, so I am solving here again. Okay, don't worry, I shall solve here all the questions. Wherever you will feel difficulty, I am here always ready to solve your problem. But you should solve. But you could qualify for the IIT main or NEET examination when you will do the work at your home also, and if you will have the sincerity. Let's see here. The number of here. So you know already. So molarity is number of moles of solute. So by the formula, okay, by the concept I'm telling you, okay. So molarity here is 0.75 molar. So then that means 0.75 moles of HCl will be present in 1 liter of the solution. Here molarity is 0.75. That means the number of moles of HCl will be 0.75 when the volume of whole of the solution will be 1 liter. So in 25 milliliter, how much will be the number of moles of HCl? That you will have to calculate. So that means here So when volume is 1000 milliliter, then number of moles is 0.75. So when the volume of solution will be 25 milliliter, then what will be the number of moles of HCl? That you will have to find out. So 0.75 divided by 40. That is, volume is this much, number of moles is this much. Okay, then after, let's see. So CaCO3 when react with HCl, so 1 mole HCl react with 2 mole HCl react with 1 mole CaCO3. So that much mole HCl will react with how much? So there is that much. Number of moles of CaCO3 will be there that much. So weight of CaCO3, atom weight of CaCO3 how much? Calcium 40. So that means 0.94 gram of CO3 will require to react with 25 milliliter of 0.75 molar HCl solution. So it's all for this class. In the next class, we will discuss about this question and the few questions which I have given you in the homework. Okay. So it's all for this class. Thank you, Team Educate.